All right, if you had the version that said AB Calculus Try 1 Final Exam, then you are going to be, instead of T1, right, Try 1, then you are going to be looking at this version 2 with me as we kind of like go over some things. So, let's look at the very first one. When we are asked, so a particle is moving along the x-axis, so its velocity at a time t is given by the following equation. I'm going to make some notes right here because whenever I'm talking about a velocity, I'm going to go like x of t, then there's v of t, then there's a of t, right? And this is the same thing as x prime of t. This is the same thing as x double prime of t and v prime of t. So just kind of like give yourself a note on like how this goes. It asks for the acceleration at time t equals 2.3. So we want to know a of 2.3, which is the same thing as v prime of 2.3. I do not know why I cannot write for some reason right now. So because I'm allowed to use my calculator, for sure, let's get that used. It also says include units, and it tells me that I'm originally in meters per second. So I'm just going to go ahead and write meters per second squared here because I'm looking at acceleration. Now, I'm asked to do a whole bunch of other things with it that's probably going to require looking at a graph. So I'm actually going to come over here to y equals. Remember, to get this in here, let me clear this out. You can go to alpha y equals to get that like stacked fraction. That way you do not have to worry about order of operations. And I'm just going to get this typed in. Now, what I saw a lot of when I was grading this grading this problem, is I saw a lot of you guys used quotient rule. It's fine, but like, honestly, I would just use a calculator if you're given one. It saves you time and it's going to be a lot more precise. So let's get this done here. I typed this into my y equals. I'm going to quit out of this and I'm going to go use my math 8 because I know that that takes a quick derivative. I'm going to put a dx, and then I'm going to go over here to vars. Because I already typed my equation into y1, I can scroll over to yvars and go on function and grab that y1. And I can say I'm looking actually for the derivative at 2.3. And when I get that, I get this decimal. It says 3 decimal places, so I'm going to say negative 0.002. Negative. And that is going to be my answer. On this equation, it was scored out of 2 points on this problem. So you got 1 point for your answer. And then you got 1 point for units. Find all values of t in the interval 0 to 2 where the speed of the particle is 1. All right, so I'm going to go over here to window. Let's go to zoom. And let's go over here to that zoom fit. And it got a lot, so I'm going to also go back over here to window and start adjusting a little bit. I probably don't want a y-max of 115, so let's give something a little bit more reasonable. Let's do like -5. This should give me a better, there we go, a little bit better idea of what's going on here. We're looking for from 0 to 2. So if I were looking at this graph, this would be my cutoff line. So I'm only looking from 0 to 2. If you want, you can go ahead and like change that x scale. Like let's go to window and we can make that x max like 3 or like 2.5 to give us that nice zoom. And we're looking for the speed of the particle to be 1. Now I know that speed is absolute value of velocity. So I'm going to say absolute value of velocity equals speed. Therefore, s of t equals 1 when v of t is plus or minus 1. So let's go to that y equals, and I'm going to type in a positive 1. And let's find that intersection. So second trace 5, enter, enter, enter. And it looks like at time 0.535, making sure I'm rounding correctly. And remember, we also have to look at -1, so I'm going to go back and I'm just going to type in, change that to a -1. And let's find that intersection. And remember, we need to make sure it's less than 2. 1.90 909 when we round. And these are your 2 times. This was also out of 2 points, and you just got 1 point for each one. Now, particle is at rest. Ooh, okay. So I remember that the particle is at rest when velocity equals 0. So let's look at this graph really quick. I'm actually going to zoom back out because now my interval is from 0 to 10. So I'm going to take this to like 11 just to get a really good idea of what's happening. And it looks like it's at rest 2 times. So it's going to be these 2 zeros or these 2 solutions. So remember, you can get that on your calculator by going second calc. Let's do that 0. It always wants you to go like left and right. So I'm going to scroll all the way, get left of that solution, press enter. Then it wants right, so get right of that solution or like below the x-axis, press enter. And then here's my first 0, positive 1. Because it has to justify, I'm going to give a little statement. The particle is at rest when v of t equals 0. V of t equals 0 at t equals 1 and 1 second. Let's get that other one. Again, going to the left, going to the right, and then getting that value, 3.464 seconds. 3.464 seconds. Also, same thing, added 2 points. So you got 1 point for the times, and then you got 1 point for the justification. So specifically, that would be saying that v of t equals 0. At time t equals 3 seconds, is the particle speeding up or slowing down? Justify your answer. All right, so we're looking at 2 things. Remember that like we need to be looking at v of 3 and we need to be looking at a of 3. So like what's going on with the velocity and the speed? Let's do second trace, let's do a value. So we're saying when the value is 3, what's going on to the function? And it is negative 8/11ths. So you can write and you can have the number, but because it doesn't ask, or you can just say it's negative, then I can just note that the sign is negative at that point. Let's also grab that derivative. So same menu, use that dy over dx. And it's saying that when x equals 3, the derivative is positive 1.12. So I'm going to say the particle is slowing down. Because velocity is negative and acceleration is positive. This was also 2 points. So 1 point for saying slowing down, right? So that's that 1 point. And then another point for that justification, and that would be like naming the fact that those signs are opposite, or like that velocity is negative and acceleration is positive. It's important to note that you do need to name more than just saying like they have different signs. Like you need to have somewhere that shows that you knew that velocity was negative and acceleration was positive in this scenario. Total for number 1 was out of 8 points. Number 2. All right, we are looking for f of negative of 5. So we have a piecewise function here. So remember with these, you're just identifying which piece to use when you're given these domain restrictions. So if my input is negative 5, it looks like I'm going to be using that first piece of the function, that horizontal line. And I'm just going to name f of negative 5 is negative 3. That is all you had to do there. That was 1 point. Is f of x continuous at x equals 0? Remember for continuity, you have to kind of like prove 3 things for continuity. So you need to say the limit, which is 0 from the left, equals the limit as x approaches 0 from the right. And that all needs to equal if those are the same thing, they need to also equal that f of 0 value. So we need three separate things. So I'm looking at what two pieces are like, where is that break occurring? And it looks like I'm going to be using these two functions, negative x minus 2 and then x plus 6 over 3x minus 3. So we have that left bound. Limit as x approaches 0 from the left. We're going to be using that 0 plus 6 over 3 times 0 minus 3, which is negative 2. The limit as x approaches 0 from the right is going to be, oh, whoops, I did the wrong one there. This one is going to be that 0 plus 6 over 3 times 0 minus 3. It's negative 2, and let me fix that left-hand bound. My bad right here. We're going to change this guy to negative x minus 2, which is also negative 2. Those equal each other. And then I'm also going to say, so the limit as x approaches 0 of f of x is going to be negative 2. And then we also need to make sure that that limit equals the value of f of 0. So I see that 0 is included in the domain for that second piece. So f of 0 would be negative 0 minus 2. So the limit as x approaches 0 equals f of 0, and it equals negative 2. Because these things exist, you're saying that it's both of the sides are approaching the same value, and we're filled in at that point. So remember, all three of those things have to be present. This guy was 3 points total. Let me go over here and grab my rubric really fast. Great, so we got 1 point for doing the left and right. So 1 point here, 1 point here, and then 1 point for saying that that value, or that f of 0, is negative 2. So we had that also right there. So remember, you're looking for left-hand limit, right-hand limit, and then that value at that point. So kind of like each of these pieces gave you like a separate point for that answer. So that total answer was out of 3. Is f of x differentiable at x equals 3? We are now looking at those last two pieces of the function, right? So that x equals 3 is the domain, so I'm looking at this guy. Remember, for differentiable, we have to prove continuity first. So this is kind of one of those that's like a little bit funkier, because we can't only just say like, oh yeah, the derivative is the same thing. So very first thing I'm going to do is I'm going to try to prove continuity here. So I'm going to like fill out that limit as x approaches 3 from the left of f of x equals, we need the limit as x approaches 3 from the right. And then we also need what is f of 3. So I'm going to be using those functions and getting those three things. I'm going to press pause for a second and do that math. So every single time I plugged 3 in, I noticed that I got that same value, or 3/2. So I'm going to say the limit as x approaches 3 of f of x equals f of 3 equals 3/2, therefore continuous. This was 1 point. You had to prove continuity first, because remember, if something is not continuous, it is not differentiable, end of story. After we went through that whole continuity statement, so like step 1 is going to be like continuity. Step 2 is like proving differentiability. So let's get that done really quick here. We needed some sort of notation or some sort of way that we are like noting how we're using, like which two pieces of the function we're using, and that we're derivating each one. Your teacher will probably talk to you more about like the correct way to do this, but for now, really what we needed to see was something like you have f of x equals, I'm just going to write down the two pieces that we used. So that x plus 6 over 3x minus 3. And then you also had that second piece, which was that 1/2 x squared minus 4x plus 9. This was for the x values. Let's get that written down. 0 to 3, and then greater than equal to 3. So I'm going to write that derivative function, and I'm going to say f prime of x equals, we're going to use that quotient rule here, so that low d high, high d low. So 3x minus 3 times 1 minus high x plus 6, derivative of the low, all over 3x minus 3 squared. And remember, that is from 0 to 3. And then this bottom one right here would just be x minus 4. So we're asking ourselves, like, when we need this to be differentiable, you need to be showing that, like, as x approaches each of these, it is the same number from that derivative perspective. So I'm going to say the limit as x approaches 3 from the left of f prime of x needs to equal the limit as x approaches 3 from the right of f prime of x needs to equal f prime of 3, or something similar there. And in this scenario, what you just had to do is like plug in these values. So because we're plugging in that 3, I'm going to go ahead and get that done. So 3 minus 4 is 1. That would also equal f prime of 3. And once I start plugging this in, I notice that this is not going to be equivalent. So I'm going to say, like, this does not equal, therefore not differentiable. Sorry, f of x at x equals 3. So you already got that 1 point for that continuity statement. You would have gotten 1 point for noting how to differentiate those pieces correctly, 1 point for the values, and then 1 point for stating it's not differentiable. So this one was a little bit of a beast. It was out of 4 points total. And again, walking through those, 1 point for proving continuity, 1 point for correctly differentiating the pieces, and then 1 point for values, and then 1 point for noting not differentiable. All right, very last one. We have our related rates. Let's get it done. 5-meter ladder is leaning against a building so that the end, all right, reading all through this, I'm like, okay, great. I'm going to say z equals 5. I always like using x, y, and z, but it is up to you. Someone's pushing the ladder towards the building. So we are pushing the ladder towards the building, and so it would assume that it's going up the building as we're pushing it. And it starts sliding up the building at a constant rate of 6 meters per second. That's going to be that dy over dt. So the change of y in regards to time, this y value, or this a point right here, is increasing at a rate of 6 meters per second. A is 3 meters up the wall, so that's y equals 3. Find the rate of change in which the base of the ladder, so we are looking for dx over dt. I'm going to also fill in dz over dt. I know if that's a ladder, remember that d whatever over dt is like what's the rate of change. Because that ladder is not going to be expanding or contracting, that's going to be 0 meters per second. Now, to get this done, let's get this written out. You're going to be using Pythagorean theorem, x squared plus y squared equals z squared. And you can actually, if you noticed right automatically that this is a 3, 4, 5, a special triangle, I can say x equals 4. You could also use Pythagorean theorem and figure that out. I want to differentiate with regards to time, so I'm going to have 2x dx over dt equal, or plus 2y dy over dt equals 2z dz over dt. If you want to cancel out a 2, you may, because that is an equivalent form. However, you do not have to. It just sometimes helps me with like working with smaller numbers. So now I'm going to plug everything in. Your x is 4. We have dx over dt. Your y is 3. Your dy over dt is 6. And that's going to be a 5 times 0. So I get 4 dx over dt is going to be negative 18 once I move that around, divide by 4. And when I get that, I get dx over dt equals negative 18 fourth meters per second. But because it says 3 decimal places, we can also get that answer. So negative 18 divided by 4. And I get that negative 4.5. There's no 3 decimal places, totally fine. And there we go. So point distributions here. 1 point for knowing that we are using some iteration of the Pythagorean theorem. 1 point for solving for the missing variable of x. 1 point for correctly doing that implicit differentiation, and then 1 point for your correct answer with units. So out of 4 total, breaking that up again, 1 was for Pythagorean theorem, 2 was for x equals, let me actually just do this at 1 point at a time so it doesn't get confusing. 1 point was for finding x. 1 point is for using that implicit differentiation. And then 1 point was for the correct answer with units. And that is it, guys.